Hi everyone, this lesson is about sequences and how we use recursive formulas to define them. So let's begin with probably the most famous sequence known. We begin with 1, second term is 1, then we add those two terms to get 2, then we add the last two terms, we get 3, 2 plus 3 is 5, then 8, then 13, and so on. And this is the Fibonacci sequence, which is very famous. Now, how would we define this mathematically? Well, we would simply state that the first term equals 1. T1 is the first term, term number 1. The second term equals number 1. And from here on in, we used a rule. The rule stated that to find a term in the sequence, we would add the one before that to the one before that. So if n equaled, say, 3, then this becomes 3 minus 1. This is term number 2, and 3 minus 2 becomes 1. So we're saying add term 1 to term 2, and that gives you term 3. That's exactly what we did. We took the first term plus the second term and added it to give us the third term. So that's a recursive definition because it is written by referring to previous terms in the sequence. Now, we should note that that formula, sorry, not T, that formula applies when n is greater than or equal to 3. That formula wouldn't make sense for n equal 1 or 2, and n is further restricted to be a positive integer. No fractions, no negatives allowed. So that's a recursive definition of a very, very famous sequence. Of course, this is not the only sequence out there that exists. We could have, perhaps I'll give you a definition instead. So here's a new one. Let's say the first term is 6, and a new term in the sequence, term n. Let's go 2 times the previous term plus 4, all divided by 2. That seems pretty good. Let's try that. Actually, I don't think I want that. I don't think I want that 2 up there. Let's just get rid of that 2. Let's just have the previous term plus 4 divided by 2. That seems better. Now, let's start writing down the terms in this sequence. Well, the first term is number 6. That's been given to us. Now, how would we calculate this next one? We would say, if I want the second term, I would want the previous one is 6 plus 4 is 10. 10 divided by 2 is 5. How would I find the next one? I'd say 5 plus 4 is 9 divided by 2. That's 4.5. I can use the calculator for these quite nicely. I'll start by putting 6 and then press enter, and that seems a bit useless, but what I did there was I stored 6 in the answer memory, and now I will write my formula by putting answer plus 4 over 2, and when I press enter I get the second term in the sequence. If I press enter again, it repeats the calculation. I get the third term in the sequence. Remember, you can go Shift SD to change from a mixed number to an improper fraction. If I do this again, 17 over 4 is the same as 4 1/4. So it's a very handy way on the calculator to quickly generate the terms in a recursive sequence. 4 1/8. That's probably enough, and we keep on going. Now, sometimes, and this can be difficult, I must admit, so sometimes we can look at the numbers we're generating and we can think of a rule for them. So remember, these are the terms in the sequence, and it's handy to compare with that's number 1, that's number 2, 3, 4, 5, and so on. So if I wanted to find a rule, a general rule, not a recursive rule, I'm looking for a formula that would give Tn, but I don't want to refer to previous terms. I can refer to n, sure enough, but just not previous terms. So let's take a look. Is there any obvious pattern going on here? Well, 6 drops by 1 to give 5, 5 drops by a half to give a half. Just pause here for a sec, I'll carry on in a minute. Okay, sorry about the interruption. Now, where was I? We were talking about the general term, weren't we? So we're looking for patterns. 6 drops by 1 to give 5, 5 drops by a half, then this drops by a quarter, this drops by an eighth. It looks like we're subtracting different amounts each time, but the amount we're subtracting changes. So that's all a bit weird. Maybe we could simplify a bit. Maybe we could just look at these ones here where it's 4 1/2, 4 1/4, and so on. That doesn't look too bad. What if we said, at least from the third one onwards, we have 4 plus, now it's either a half, or a half times a half, or a half times a half times a half. This sounds like powers. And the power would be, in this case where n was 3, the power on half would be 1. In this case where n is 4, we'd want half squared. So it looks like it's n minus 2 as the power. Now that rule would work nicely if n was greater than or equal to 3. And once again, n would have to be part of the set of positive integers. No fractions, no negatives. Now how do we go though for term 1 and term 2? Well, we put them in the too hard basket and we just say term 1 is 6, term 2 is 5, because they don't fit the pattern that we saw, but that pattern that we saw carries on from term 3 onwards. And we would call that the general term, because that formula refers to n as a variable, not Tn, not a previous term in the sequence. So that's the difference between that one. Recursive this refers to previous terms in the sequence, and this is a general formula. Well, from 3 onwards. Because that is going to be referring to the pronumeral n rather than previous terms. Alright, that's a fairly short little introduction there for you on sequences. Often we use recursive definitions, sometimes we use general definitions, and occasionally we start with a recursive definition and then we can figure out a general formula if we look for the pattern. And admittedly, that last bit can sometimes be very tricky. Alright, that's enough for now.